The battery is a backup power for the train. It supplies 110 volt DC to the emergency load for at least 60 minutes in case of battery charger failure. The battery box is a metal case where the battery is located in. The metal case protects the battery against dust and water. The battery box is located in the underframe of each M car. It ensures that the battery is connected to the charging circuit and provides short circuit protection through the battery fuses. The type of the battery used is nickel cadmium. Following are the parts of a cell: cell box, positive terminal, negative terminal, cell cover, water top-up plug, arc back protection system, the hose pipe connections, the terminal connectors, terminal covers, the sensor. Terminal nut, cell terminal, and the separator. The main battery box and the battery box cover, right cantilever and the left cantilever, lock pins 1 and 2, pins 1 and 2, roll out trays, ventilation holes, drainage holes, and the battery control box. The functions of the parts are as follows. The water top-up plugs are used to top up distilled water into the battery cells. The water is pumped with a steady flow rate into the top-up system, and it flows into the cells one after the other. In the process, the air inside the cells escapes through the vertical tube of the plug. As soon as this tube submerges into the electrolyte, as the electrolyte reaches its maximum level, the air no longer escapes and the water intake stops. The water top-up plug is sealed off from the cell with two O-rings so that the air may escape through the plug but not directly from the cell. This is absolutely necessary for the cell to work. The arc back protection. Hydrogen and oxygen formed while charging are fed through the hose pipes to a central degasification facility with backfire protection and thus released into the environment in a controlled manner. The hose pipe connections. There are two hose pipe connections in each water top-up plug. The individual top-up plugs are connected to one another with these hose pipes. In this manner, they are connected virtually in a series to form a water top-up chain that helps in topping up distilled water. The rollout tray system is provided with the necessary stops and locks to limit the travel of the battery box and retain it in both extreme positions. When rolled out, the entire top of the battery is exposed. All the battery terminals, including the battery positive and the negative main connections, is easily accessible for maintenance work. The terminal covers provide protection to the cell terminals from dust, dirt, and prevent them from any mechanical damage or wear. The battery box is ventilated to ensure that it is not hydrogen gassing to avoid an explosion. Battery fuses and the BIS, that is the battery isolation switch, are fitted in a separate box called the battery control box, located adjacent to the battery boxes, which enable easy access from the track level. During the maintenance process, the battery is isolated from the charging circuit via the BIS or the battery isolation switch. There is one group of battery on each M car. One group of battery is divided into two halves. Half on the right side and half on the left side of the M car. Every group of battery has 45 cells combined with 40 real cells and 5 false cells. The false cells are only the cell box. They are installed upside down and are not connected to the battery circuit and the water filling system. This is the arrangement of half group of battery. The location of the battery box is shown in the following schematic diagram. The initial capacity of the battery is 260 Ah. The emergency loads connected to the battery system are as follows: saloon lights, all exterior lights, HVAC supply fans, PAPIS, all control circuits, door control, TCMS, ATP and the ATO. The main technical parameters of the battery are as follows. The following is the description of the battery box.